really like books. So, have you ever had this thing happen where you're thinking about, this was my best slide, by the way, so if you don't give me a laugh for this, then I'm not sure where this is going to go. Have you ever had this thing happen where you're reading a book and you think to yourself, man, I really wish this book was more interactive. I wish that I could see everyone else who's reading this book right now and talk to them and find out what they were thinking about this particular passage. Because I know I haven't actually had that thought. It seems like something that you would think, but I've never really thought that before. I mean, there's times when I'm reading a magazine or something, and I find my fingers curling into the define word chord. Do you know this? It looks like this, define word, and because I see a word that I don't know the definition of, and I want to like have this pop-up happen, right? But that's it. I scoured my memory. That's literally the only time that I wanted paper to be more advanced than it is. So I think there's something here. I think we look at paper and see it as paper, and we don't really expect it to be anything but paper. And likewise, we look at a phone and we think of it as just a phone. We don't expect it to be anything but a phone, right? I don't find myself, when I'm talking to someone, wishing that the phone was more than it is. I might find myself wishing that they were here with me, but that's an issue of locality and proximity and space-time. It's not an issue of the phone not being a good enough phone. So now we have phones like this that are multiplexing over phone and camera and music and computers, and that's great. But each of those is kind of this separate modality in some sense, right? They're a separate experience. And where I'm going with this ultimately is that we should be thinking about web applications as something other than the way that we think about them, right? So if we take a little history back to the web, there was a time when the web was just documents. That's how it started, right? It was hypertext documents on the internet. This was a beautiful thing. But what happens after that? Well, we get forms, and then we can, they are really excited about that. We can use these forms to actually ask the server to do something for us. So now we have a different metaphor, right? The web is documents, but the web is also these kind of primitive applications, right? And then something terrible happens, and everything dies. And were any of you there in the DHTML era? Yeah, okay. You've got the scars and you're proud to raise your hand for that. So now we have these single page applications, right? So this is a good thing. You're probably all familiar with the term single page application. We've got this. This is what the web was. It was hypertext documents and form-driven applications. Those are two different modes of thinking about the web. We've got what the web is now, which is single-page applications and desktop applications, and maybe some interactive games. Maybe there's a couple of other modes that we could stick in there. But what I'm really interested in is what the web can be. And I think what the web can be is a place to have immersive experiences and a place to interact with other people by using the web to facilitate these interactions as we're editing text documents, for example, right? There's a great advantage to editing text documents over the web because you can edit them collaboratively in real time with other people. And this is an amazing thing, but we don't really know how to think about that yet, for the most part. And when we think about the web, we're not thinking about that. So why do we want to do this on the web? There's a lot of reasons. One is that the web brings a massive audience and that it's cross-platform in theory. But really, we wanted to do this because the web is the way of building applications right now. The browser is an operating system. The web is your app store, right? Every URL endpoint is a potential application that you can install on your computer and execute without doing anything. Anybody anywhere can do this on any device. This is a really, really cool thing, right? Because typically you wouldn't install an application from an untrusted third party on your computer and run that. You wouldn't do that. But you do that every time you visit a website, every time you go to a web application. This is really exciting. So if we want to bring interactive experiences out of this, how do we do that? That is supposed to be a black box. Apparently my emoji skills are limited. Right, so we have to have some inputs, we have to have some type of black box in here that those inputs are coming into, and we have to have some outputs from them. That's pretty straightforward. So what do our inputs look like on the web? Well, we've got a few of them. We can load pages using HTTP, and we can also use XHR to use the same HTTP protocol to make a request back to the server from the browser. Okay? So we load the application, that's our initial HTTP request, by going to a URL in the browser. And then that application uses AJAX to send a message back to the server and get a response back from it. Great. We can also use WebSockets and server-sent events and WebRTC and PostMessage to communicate from our page to other things, either server or other peers, other browsers, or other Windows or iframes using PostMessage. We can do things like geolocation and orientation. We can obviously take inputs from mouse, keyboard, and now touch. That's been around for a while. And we can access newfangled things like the gamepad, MIDI controllers, the microphone, and the camera. So this is really exciting, right? We have a lot of potential inputs that we can bring into our application on the web, and a lot of those work right now cross-browser, as long as your definition of cross-browser excludes OLID. So this is great. This is a great position to be in, and I want us to, hopefully by this point I've said a couple words that have got you excited about how we can do this and what this will look like when we start doing it. So now we're going to slow down and figure out how to do it by looking at some code. So I'm glad almost all of you raised your hand when I asked if you were developers, because pretty much we've gone through the philosophical portion of the talk that I talked on in the beginning to try to bring people along with me on this ride, and from here on it's pretty much just code, and then maybe if we have time, a couple of demos at the end. So how do we, so I'm trying hard to limit the amount of code that I put on the screen, but at the same time, this is all you need to do XHR on a modern browser. Those of you who raised your hands and said you were there in the bad old days of DHTML, you know what writing one of these looked like back then. It was 10 or 20 pages of code to write a wrapper around XML HTTP request. It was brutal. Now we can do it in basically 5 lines of code, right? So we get our XHR, we set a callback for it on the ready state change, and then we open up the connection using get. You could use post instead. And we don't send anything over because it's a GET request. This is it. This is all you need in your JavaScript to get that XHR back and forth. Now, we typically are going to be using, or you are maybe typically going to be using something like jQuery. I'll say we, I don't mean to, yeah. Right. And jQuery is great if you have to support old browsers and have things that work across different domains. It has a lot of error handling that it does for you when you do $.ajax or any of the $sign functions that actually boil down to this. But it's also good for you to know that if you're in a mountain cave and you have to scratch code on the wall, this is all it takes to get that request going. All right, so essentially what we're doing now, I don't know if I made this clear, we're going to go through this list and look at how much code is required to do pretty much all of these. This is what it takes to do that. XHR, this is WebSockets. So we've got some code on the server. I'm using Socket.io. If you're using Node on the server side, this code will effectively just run. It's setting up a socket on port 80. You might want to do that on another port. But port 80 is great. And we're just going to listen to incoming connections and then emit an event. That's the fourth line, called news. And the object that sends out is going to be, will have a key of hello and a value of world. and then we're going to listen to an event called my other event, and then we're going to log that into the console. And that's it. That's all you need. Have any of you done this before or something similar to this? Okay, cool. So some of you already know that this is really quite simple. And WebSockets are great, partially because of their simplicity. They move along the same connection pathways that the basic internet does. So you don't run into a lot of issues like we will when we get to WebRTC. This is what it looks like on the server. I should also mention, I'm using Socket.io here. You can use Sock.js. There's a lot of other variants. Sock.js is nice because its API is essentially an exact mirror of the WebSocket protocol itself, whereas Socket.io adds a lot of additional things for you, which is both good and bad. It takes you further away from the underlying protocol, but it gives you some extra niceties. So you have to decide what's right for your particular application. But on the server side, you have to use something, because Node doesn't support WebSockets out of the box. So you need something there. And Socket.io is a decent way to go. Here's what this looks like on the browser side. Effectively, we've got a call to this magical /socket.io/socket.io.js thing. And then we're using that socket that is magically or we're using rather IO, which is a magically created variable after we call that line of code. So there's a lot of deep magic going on here, but that's all Socket.io. This part is when you say require socket.io.listen80, that's generating this file for you, so that over here on the browser we can pick that file up and begin using all of the stuff that it gives us in the form of IO dot. Does that make sense? It's magical. And then we're just catching this news event when it comes in, and we're sending off another event called my other event. So if we actually run this code, we're going to see data show up over on the server's log, and we're going to see the object that we're sending here, the hello world, show up in the browser console. And this is all you need to get WebSockets. And as soon as you have WebSockets, you can start connecting all of the visitors to your web application with each other. So we actually may see a demo of that a little bit later on, if you have Wi-Fi connectivity, and if I still have it, maybe. So WebRTC, how many of you have used this before? Okay, cool. WebRTC is amazing. It allows you to connect browsers directly to other browsers. This is an incredible thing, right? Because until now, your application was essentially a silo, and all of the visitors to your application were locked into that silo. So WebRTC does two things. One, it allows you to have peer connections between browsers that go directly to each other and don't use your server as a trampoline for that data to bounce it from person to person. This is really, really good if you want to do any type of audio or video, right? So you may have seen these demos online where people can video chat with each other using their browsers. And ideally, that's not going through a server. That's directly peer-to-peer. And it's a good thing because it's a lot of traffic, and you don't want thousands of those connections hammering your server. But additionally, you don't have to limit this to audio-video. You can do it with data also. And that's what we're seeing here. This is using a wrapper library called Pure.js. But the underlying specification for this isn't too bad. But I would suggest using a wrapper library for WebRTC because it's, in the edge cases, it's inherently difficult to do this type of thing. The reason is that I mentioned before that we're working in a sandboxed world whenever we're in JavaScript. So if you're in your browser and you go to a URL somewhere, you're loading an application, and then you're executing that application in your browser on your machine from an untrusted third party. It's fantastic that we can do that, but as an application developer, it means that your hands are kind of tied in some ways because the browser, the operating system for your application, has to sandbox your application. And the reason we have to sandbox this in particular, and that we get into trouble with this, there's a few reasons. One reason we get into trouble in general with WebRTC is that most people are still using IP version 4, where there's 4 bytes in your IP address. And there are too many machines online right now for that to actually work. If we were using IP6, where you've got 6 bytes in your IP address, then everyone could have a uniquely assignable IP address, and it would be a lot easier to figure out what your IP is to the outside world, right? So you've got one IP to the inside world, you've got one IP address to the outside world, and there's a router somewhere that's taking care of traffic coming in and making sure it gets to you. But if you want to have a direct connection with some other person, you need to find what their external IP address is, and all they know is what their internal IP address is. So this is already kind of problematic and tricky, but there's a much nastier problem to overcome, which is that your router, in addition to taking care of this routing, is also protecting the local network that it's generating. And it's protecting it from all of the maliciousness on the outside. Right? So inside your local network, you can plug some device in, and it finds your Wi-Fi, and then it starts connecting to all of your other devices. It's doing this essentially by doing a port scan, and then finding other devices that it can talk to, and it talks to them, and everything's talking to each other, and it's a wonderful world that we live in. But that only happens in this kind of walled garden of your router's local network that it's generating. If we let just anyone out there, right, in the general sea of the internet, do a port scan on all your devices and talk to them directly, this would be a really, really bad thing, right? What is it, like 5 seconds from plugging in an old PC to the time that is bot infested, full of terribleness? I think it's about 5 seconds these days from the time it goes online. This is a really bad situation to be in. So if somebody could write a web application that had access to your local network, then you, on the inside of that local network, load up that web application, and suddenly it's doing a port scan over all of your devices and sending all of that information back to the server. This is a really bad place to be. So this is actually not as easy as it looks. All of that to say, this is not as easy as it looks. WebRTC is hard because you have to have external servers that deal with punching holes in firewalls and routing the connections correctly. So essentially, you have to either set those servers up yourself or lean on third-party providers. There are some that make this really, really easy to do. Are they watching a demo over there? I don't know if you can hear this as loud as I do. It's all I hear. Yeah, so RTC is great, but because of our sandbox in the browser, it's a little hacky still. And if you want to set up a full stack, there's a lot of work involved. You need to set up a nice server, and a stun server, and a turn server. So all of that to say, use Pure.js and use someone else's stack. Because there are people who give you this for free, like Google or Pure Server or other things like that, which is a good place to be. I'm not going to advocate for any other wrapper libraries. We'll just look at raw code from here on. So this is the location API, which is really cool, actually. It tells you exactly where you are by asking you, the browser user, a question saying, can this site have access to your location? And when you say yes, then you, as the app developer, get access to the longitude, the latitude. You have an accuracy measure. You have a timestamp on that. There's a lot of things that go into this. It's a very cool property to have if you're thinking about making interactive applications, right? Because suddenly you can not only just give someone some information, but you can give them information that's very specific to them and the people around them and the things around them. And usually we think of these in kind of a mobile device way, but you can do this on the web too, using this kind of API. Maybe I'll pause for a moment for questions. I know they're usually at the end, but we've covered a lot of material fairly quickly. Anyone have anything in particular they'd like to talk about? Nope? Good, good. Orientation. So, actually maybe we'll take a look at this one. I think I still have it up somewhere. I think you need a break from code slides. We haven't gotten there yet, but this is what the W3C thinks a game controller looks like. Is this it? Oh, yeah. So this is using that device API I just showed you, like 2 lines of code. You can see as I tilt my laptop, it's very small actually moves.
It's not on screen.
Ah, dear. Thank you. That's going to look great on video, huh? Yeah, so now you can see, and I can't see unless I look over there. That we actually get this effect where I'm tilting my laptop and it's picking it up. So with a laptop, maybe this is not, the most useful thing, but this works on mobile devices also. And it's just one more way that we have interactivity with the people who are using our applications. And the code for this is ridiculously simple. Maybe I'll bring that back and actually show you what the code looks like, because all I'm really doing there is giving you some API calls. This is on the developer.mozilla.org site, by the way, which is a great place to go to find out about new APIs and how to use them. So they're doing some slightly weird things. Most of this you don't need to know about. This is the important part. So we're getting a beta and a gamma. These are just angles that are coming in, and essentially converting them to an x and a y. And then throwing on some constraints. And then moving the ball's position. And that's it. That's the entirety of the code that makes up this little demo. Still working? It is, okay. Manually moving it back to the other screen. There's got to be a faster way to do that. So as you can see, there's actually two different types of API here. One is for screens, those first two lines. And the second two, or the second pair rather, is for devices in particular. So we were looking at the device orientation. There's a completely separate API for screen orientation. MIDI, this one's exciting. Have any of you played with this at all? It's very, very new. It's still in draft state, but you can currently download a plugin that allows you to run essentially this code in your browser. It doesn't run natively anywhere yet, but it will soon. And it's not, maybe you remember 10 or 15 years ago when you would go to a web page and it would load up a little MIDI tune and play that. Yeah, this is not what that is at all. This is low-level access to MIDI devices and essentially anything else that's controlled in a MIDI style. And as you can see, I mean, do I have a bunch of, I do. We're getting, essentially this event is giving us a chunk of, data. So I can point, but I can't click. This event is giving us a chunk of data, and that's just bytes that are coming in. I don't actually know if they're in a typed array. They're probably in a typed array, like an array of single bytes that is a certain length. This is amazing, and it's going to completely revolutionize the way that web applications have access to connect to hardware peripherals. And the other thing that's going to revolutionize that, and it is currently, this is active and available, is the gamepad API. So you can make a request directly to anything that has registered with your browser as a gamepad and track its information. And it's this simple. I mean, this is the raw code. There's a lot of good stuff hiding in this navigator object, like the get gamepads function, but also the location, the geo-orientation stuff is in there too. They're putting some interesting things in there. So if you have a chance this evening, go to your JavaScript console and just type navigator and look at all the fun stuff that's inside there. Right. Microphone and also video use the same WebKit, get media stream is what we're really trying to do. That's down here. Have any of you done this before, this real-time video or audio tracking? It's really, really cool. Okay. So there's a couple of things baked in here. One is this WebKit audio context. I lost my pointer. This guy lets you set up these audio nodes. And I've given some talks about this in the past. I don't think I have a demo prepared for this one. So unfortunately, we won't look at that. But it's incredibly cool stuff. So you set up these audio processing nodes and then wire them together into this network. So we're doing kind of the simplest thing you can possibly do here, which is also kind of the worst thing that you can possibly do. We're creating a new context, and then we're calling navigator.getMedia down here. we're passing in these constraints, which is just an object with a key of audio and a value of true. We're passing in a success function and an error function. Our error function is just logging out the console. The interesting part's in here. We're taking the context. We're creating a media stream source from the stream that we get. Is that going to work? Yeah. That's not going to work. This should say local media stream. Yeah, oops. Sorry. Should have tested it. But I didn't want to test it because we're immediately connecting that to our context.destination, which means that we're taking the microphone input and immediately feeding it out into the speakers, which means that in my case, my microphone and my speakers are like that close to each other on my laptop, and you immediately get feedback, and it is really loud and annoying. So I didn't test this one. Sorry. I will change that on the slides if you download the slides. And we can do the same thing with the camera. It's almost exactly the same. That last line is exactly the same. And in this case, we actually do have local media stream here, which is good. We're pretending that there's a video and a canvas object out on the page somewhere. Our constraints are a little bit different, but this is essentially exactly the same thing. We're just dealing with both video and audio simultaneously. So essentially, there's a whole bunch of tools that are available to you for doing really, really, really cool things, and they're amazingly simple to use. That's the theme of the talk. Hopefully I've managed to inspire you to try some of these things out and start introducing them to your application. Hopefully in measured ways. If you're writing a business application, don't introduce too many things at once. We'll be back into the DHTML era in that case. So let's look at a couple demos. How do we do this? So I'll pull this back over here, and I'll bring my Mac, I guess. That'll work. So if we go to, this is going to be off here. It turns out if you turn your head like this, you can't actually type anymore. Is this the wrong one? That's the wrong one. So this is always that magical moment in a presentation where you wonder if your Wi-Fi is really going to work or not. So instead, I'm going to try to set up tethering really quickly. If you have a device that has internet access and you go to over here, that's quite too large, isn't it? Slightly upstream. If you go here, the first go there. Okay, bentodojo.com:8802. Is anyone managing to connect? Raise your hand. One person. Oh. Okay. Person hotspot. Sorry? It is a blank screen until you touch it. And then if we all cross our fingers, maybe I need to reload this.
Yeah, seeing something.
Oh,
Are you?
cool.
In theory, anywhere you touch, it should show up as a dot. And the color of your dot is going to be based on some random property of your device. Oh, good. That's what I was looking for. Okay, successful demo. Yeah, sorry, the canvas is actually kind of small, so if you have a high-res device, you have to poke it right in the corner for anything to happen. Okay, so now I'm going to show you something that will potentially break all of this, if I can remember how to do it. Let's look at the code for this really quick. This is so weird that you can't see any of the stuff that I'm seeing. so badly. Okay, nice. It looks like there's maybe 8 people connected. How many are on? How many tried to get on and couldn't get on? Okay. So here's what the code for this looks like. Somewhere. This is the application on the server side. We're using exactly that same code that I showed you before. This is just setting up the node application to begin with, and this is doing all of our listening. And we just listen for an event called bounce, and then we send a signal called bounced. And over here, we're doing something very, very similar. We're setting our queue initially when you first log on. So this is math random. It gets us a random number. We multiply it by 360, and then we cast it to an integer. And then we're getting our canvas context, and we're creating our socket connection using our magical I/O that we get from this line. And then this is it. Like every time you click in the canvas, it emits an event that looks like this. And then when it receives an event from someone else, it's going to be putting it into your canvas. We've got 10 minutes, is that right? Okay, so what happens if we just take this line and do something vaguely horrible, like open up our JavaScript console and do this directly? We'll just change this to 0, change this to 0. We'll keep Q as my Q. And in theory, what is my color?
Just change it to black.
Actually, don't think there's a black available because I'm fixing the saturation and the lightness. One of the nice things about using HSL as opposed to RGB, and usually when I talk about this kind of thing, I'm talking in a room full of developers, so I know more about design than they do, but all of you probably know more about design than I do. So HSL is nice because you can fix 2 of the values and then twiddle your hue, and it gives you a nice color palette. So all of these are kind of blending in a moderately, okay, it's kind of hideous, but in a moderately nice way. Whereas if we were just picking random RPG, it's not an RPG. If we were picking random values from the red, green, blue color space, we would have a more difficult time. Okay, so this is awful, and I apologize in advance. But we're going to do something like this. And if you have a JavaScript console available to you, then you could do this too. And it will also be awful. So in theory, if my internet connection holds up, I'm sending a whole bunch of packets over to the server, and it's bouncing them out to all of us. And I may have just destroyed everything.
Is that for loop qualifier in the wrong spot?
Is the for loop qualifier in the wrong spot?
Do you have the
yes.
condition
Thank
for
you.
the you have the condition?
Wow. I have never made that particular error while live coding before. Yes. Yeah. And you can do this too, but play nice. Okay, I think that's enough of me trying to pretend to live code for today. So I have a second demo for you if you like clicking buttons as opposed to writing code in the console. This one is at :8801, and it is needing to be reloaded. So let's look at the code for this really quick while it loads. Essentially, we have a massively multiplayer market simulation, and there's this is the server side. So on connection, we have a rate and a velocity. And then as you buy things, we're modulating the velocity. If you buy a bunch of stuff, then the price goes up. If you sell a bunch of stuff, then the price goes down. Come on, little phone, you can do it. And then every 1/3 of a second, you can see that we're doing a calculation and adjusting the current market rate. And over here, we've just got a couple of simple buttons. And in theory, okay, we'll come back to this one. Does anyone have any questions while we wait for these things to load? Yeah? Okay.
I'm not sure what exactly you use with the API. Like what type of devices do you use?
With the MIDI API?
Yeah.
In theory,
USB would be more useful.
it does seem like that. I think it can read, so the gamepad API can read raw USB, I believe, but that doesn't give you the interfaces that you need for things. I'm not really a hardware person, so probably
That might be interesting.
other than the standard MIDI like synthesizers and drum kits. I don't. It's a very new API. In fact, I just discovered it while I was prepping for this talk. It's still in draft stage, so it's not in any browsers. And if you go to caniuse.com, which is kind of the standard reference for figuring out whether an API is baked enough that it's available, the MIDI API, I think, isn't even in there. So it's not really fully formed yet. But if you're interested in experimenting with it, I'd love to hear what you do with it, because I think it's going to give us a lot of interesting abilities. So yeah, no one else is playing along with the do-it-yourself. Sorry? That's right, yeah. Last time I gave this demo, the whole screen exploded. It was a terrible mess. Yes?
I was wondering, for the socket I/O, how would you deal with scalability?
Yeah, so socket I/O in some ways is nice in terms of scalability, because you're only opening up a single TCP connection between the browser and the server. Whereas if you're doing a lot of rapid AJAX connections back and forth, and maybe you're doing long polling on top of that, then you're opening up essentially a new connection every time you do this, right? So if it's your TCP pool that you're worried about, then sockets are kind of a nice way to go. But you're right, if you get too many people on that one server, you can have an issue. Fortunately, baked into the WebSocket protocol, there's the ability to hand that connection from a load balancer to a particular server. So if you've got a bunch of servers behind a load balancer, you can have some code in there that hands that connection over. It's transferable. And so you can scale out horizontally still without having to keep everything on the same box. WebSockets are really one of the only ways that we have to have a full duplex connection from the browser to the server. So if you want to have a conversation with the server, as opposed to just asking it questions and getting an answer back, if all you want to do is ask a question of the server, you can just use XHR, use AJAX, and that works great for that use case. But if you need communication to go both ways and have a full conversation, so the server's sending you events and you're sending it things, sockets are really the way to go. I didn't talk about server-sent events, but those are another possibility here that can either complement a WebSocket connection or replace the sockets. And going one way, you're using AJAX, and going the other way, you're using server-sent events. In terms of scaling, though, which one of those is better really depends on the frequency of communication and the size of the data that you're sending back and forth. So how often you're doing it, how much you're sending, kind of the latency that you need, and the number of users that you need. beyond that, it's like server hardware level magic, right? Which is kind of that ops side of things is a little out of my domain. Did that answer the question?
Yeah.
Anyone else? Oh, this is up. Oh, you guys are really driving the price up. So, if there's a bug in my code, I've never seen it execute, but just thinking about it, I'm pretty sure that if you get the price down to 0, the entire market will crash and everything will explode. But to do that in less than 5 minutes, you're going to have to wait. So, any other questions? Yes?
Concerning WebSockets,
Yeah.
are there any concerns regarding like cross-site request forgery?
Are there concerns regarding cross-site request forgeries vis-a-vis WebSockets? It's an interesting question.
Do you send tokens first? Do you send like tokens for authentication or?
Yeah, no, your browser is establishing a direct TCP connection with the server. So if you're doing this over HTTPS, then in theory you should be secure, in theory.
Have you heard of the vulnerabilities? There's some that were identified on Django, it's a Python framework.
Yeah, yeah.
Where there were scripts that could exploit.
Yeah, they could exploit.
Sockets.
Interesting. I haven't heard of that, no. Cross-site request forgery is probably happening on the kind of the client side of the client, if you will. Like
Right.
that's about pushing things into the HTML that you're displaying. And it's been so long since I've looked into these particular vulnerability vectors. I don't exactly. Yeah, off the top of my head, I'm not seeing how that connects to WebSockets. But I'll have to look into the Django issue.
But assuming like you're using a third-party service, I guess you're not really worried about.
You're using a third-party service for WebRTC, most likely.
Yeah.
Yeah, but for WebSockets, that's a direct connection to the server, so you don't need any third parties involved. And in theory, if you're doing that over a secure connection,
Should be okay.
yeah, you should be okay.
I was just wondering if you knew if Socket in particular or any of those do like garbage collection, or if you have to manage or worry about the resourcing.
It's a good question. Garbage collection over the connections on the server side?
Yeah, I guess if the server needs to, you need to manage that yourself, or if it automatically handles killing connections and reallocating.
Okay. Yeah, so when a connection closes, Socket.io includes a callback that happens at that point. But internally to it, it's managing the closed connection